Hi everyone. So we're going to get started with a little review question. Number one, I asked you to factor that expression. So if you look at the three terms, you're going to first ask yourself, is there a greatest common factor that you can remove? And you might be tempted to remove a number like 12, but you notice that the last term, the third term over here, does not have a coefficient that allows you to factor that out. So the greatest common factor here is actually x squared. So I'm going to go ahead and factor that out. And we're going to be left with x squared. I'm going to have 36x to the 4 plus 12x squared plus 1. So look at that expression now. Leave the x squared, the GCF on the left alone. Look at the trinomial you're left with here. Examine the 36 and the 1. If you notice, those are both perfect squares, right? 6 times 6 is 36. 1 times 1 is 1. And because there are three terms, we're going to factor it like this. I'm going to leave my GCF, x squared, out to the side. I'm going to open one set of brackets and I'm going to write 36x to the 4 as its square root, or 6x squared. You want to think to yourself, 6x squared times 6x squared is 36x to the 4. Then, because the sign of the middle term, the 12, is positive, I'm going to add a 1, because that's the perfect square of 1. I'm going to close the bracket, and I'm going to write the exact same expression. So 6x squared plus 1. Close the bracket. That is how you factor a perfect square trinomial. Feel free to rewrite this. Let me copy and paste this one again. What we could do is simply write one of the identical brackets and raise it to the power of 2. That is allowable and will shorten your answer, but they're both acceptable. So that should be pretty easy. Moving on though to the warm-up question number 2. This is what is really the main idea of 5.6. Now there were 3 sections in 5.6. This summarizes all of them pretty well. So here's your function. F of x equals x plus 2, x plus 3 times x minus 1. And I'm asking you, what are the zeros of the following function? The zeros are the x values that make the equation equal 0. And we'll see that on the graph in a second. But just by looking at the algebraic model or the equation, you should be able to pick out the numbers that make it equal 0. They're going to be the numbers that you see in the brackets, only with opposite signs. So the zeros are -2, -3, and 1. And we can state that as x equals -2, x equals -3, and x equals 1. Moving on to the next question. Evaluate the function for x equals 3 and x equals 1. Just a little hint on the vocabulary. Whenever you see the word evaluate, it's asking you to take the number and plug it into the function. You should remember from grade 11 that function notation tells you that you can write it like this. F of 3 is equal to 3 plus 2, 3 plus 3, and 3 minus 1. So we can quickly evaluate that. The first bracket is 5 times 6 times 2. 5 times 6 is 30, and 30 times 2 is 60. So f of 3, or the function at 3, is equal to 60. Now what about f at 1? Well, that shouldn't be too difficult for you to see because 1 was actually one of our zeros. So if we put 1 there, 1 there, 1 there, and 1 there, this third bracket alone should tell you right away evaluating at 1 is really just giving you the 0. So it's going to be that like that. And finally, what is the y-intercept of the function? we're going to show these points on the graph. The y-intercept can easily be found by plugging in 0 for all of the x values. So whatever your function is, even if it's not in factored form, which this is, you can still do this process. Put 0 there, 0 there, and 0 there, which gives us 2 times 3 times -1, which is -6. So your y-intercept is shown there. Now if we head over to Desmos, I'm going to graph this function here, and we're going to relate those zeros to the graph. Just move over here. Here it is. I've entered it on the left. Notice how the zeros line up with what we found. I'm going to zoom in a little bit, and we can highlight them there. -3, -2, and -1. These zeros are going to be important for some word problems that are coming up really soon. So remember how to find them from factored form. Also, the y-intercept, which is down there, 0, -6, is shown on this graph. A couple other things you should note from earlier sections in Unit 5. This is a cubic function, so the maximum number of x-intercepts that this function can have is 3. It doesn't mean that it has to have all 3. In this case it does, which is nice, but it can never have more than 3 x-intercepts. The end behavior, well, if x is getting very large in the negative direction, y is also getting very large in the negative direction. So y goes to -infinity. As x gets larger, then y is also getting larger. Y heads to +infinity. So a neat little cubic function just to get your minds on. After you finish this video, head on over to the rest of 5.6, finish that up, and look at some of the practice problems that will reinforce these ideas.